Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hello, everybody. It is January the 29th. We are almost through the month, which is really hard to believe. The month that seemed like it would be interminable 4 weeks ago is nearly finished. And I remember from my foundations days, I always thought that these 6 weeks were the hardest 6 weeks of the year. And so hopefully, as we've been working through our book club and looking at the math map and the gorgeous art, you have been encouraged to enjoy this time. So this week we are looking at lesson 21, which is locations. And that is here in 3D. It is our third of 4 lessons in 3D. And we're going to talk about about the content this week, but one of the reasons why we looked at calling this locations and then next week populations is to reflect that idea that we are working our way through human space. And when we think about the space around us, where we are really matters. And our location matters. And so knowing where we are is essential to knowing where we're going, right? Or where we've come from. And so that's one of the reasons why this week is called locations. And next week, we're going to be looking at statistics as well as our classical skills of learning. And you're going to see there, we're calling it populations because we're going to be looking somewhat at how do we look at people, right? So populations doesn't necessarily have to just mean people. It has a broader understanding in statistics especially, but when we think of populations, we're thinking of people. And so we just wanted to keep those ideas at the forefront of our minds as we're talking about moving through human space. So as you know, this year we are working through the complex domain, which is our first printed domain. And we are doing this as though we were in a Challenge A community. So we're using our in-class community outline, working through complex. But those same concepts are also available in those digital lessons. So the digits, the naturals, and the fractions. So depending on where you're at in your mathematical journey, one of those domains may be a more friendly entree into the concepts that we're talking about. And the beautiful thing is that whatever domain you're using at home, you can follow along and have a unified conversation about those topics. So we are on a new game. We are going to transition from where we've been talking about our interesting integers to using some games from Quick Flip Arithmetic. As you can see, I put a little picture of the book in the upper right-hand corner there, and you can pick, if you're a tutor, you can pick any game. If you're a parent, you can pick any game from this book, and you can adapt it to use it at home. For our tutors, we have put together a document that has a couple of the games that you may want to use during this 10 weeks that we're going to be working through. And we've also put some ideas in that document for how you could adapt this game for different domains. So the one I chose from that packet today was the distributive property. And what I'm going to do this week is I'm just going to walk through how you might play this at home. And then in future weeks, we'll take a look at how could we adapt this to different domains, whether that's our younger children or our older children. How can we adapt this and see that we can get really an infinite amount of practice for what we're working on. So this week, as we flipped cards, it's called Quick Flip Arithmetic because you use a deck of cards and you literally are going to flip cards. So I flipped a 4, a 6, and a 9, and we're just going to put those in order. And the first thing that we could ask our students to do is to write right? And so what would you write? I would write in the form of the distributive property. If they remember their foundations memory work, they may say A times opening parentheses, B plus C closing parentheses. Um, I, as a math person, would say A times the quantity, B plus C, right? So however your students have memorized that, you can help them to see that when we're flipping these cards, that first card is our A, that second card is our B, and that third card is our C. And so now we can take that form that we've been memorizing, and our memorized form now tells us how to put those numbers in. And so we could write 4 times 6 plus 9, and then we could read that, right? And so again, you may have students who want to read it in the same way they did in foundations, 4 times opening parentheses, 6 plus 9 closing parentheses. I would probably start to transition them to using that term quantity instead of opening and closing parentheses, because that's going to be a little less clunky over time. So I would read this as 4 times the quantity, 6 plus 9. And then in this case, when we're doing this with numbers, I would work through how to calculate this both ways. So the first way to calculate this is by using our distributive property, right? The other half of that, A times opening parentheses, B plus C closing parentheses, is equals A times B plus B times C. And so that's what we have here is we're working through, let me get my pointer here, right? So that's what we're doing here in this first line is we're just substituting our numbers for A, B, and C. Then we've got A times B and A times C. And when we work that through, we get 60. Your students who have been practicing the order of operations might push back and say, why wouldn't we simplify our parentheses first? And using the order of operations, we would simplify 6 plus 9 to 15, and then 4 times 15 gives us 60. And so when we're doing this with numbers, one of the things we can help our students to see is that we can use that full expression of the distributive property to demonstrate to ourselves that it really does work and to help us to have confidence in this law. Now, in the future weeks, we're going to talk about cases where we can't simplify, right? Where the order of operations isn't going to apply because they're not like terms. And so that's one of the things you could talk about with your students is why can I do my parentheses first? Because they're like terms, right? I can add 6 and 9. You could even say to them, what if it was 6 halves and 9 thirds? Are those like terms? Well, in that case, they are. So that was a bad choice. But maybe 6 fifths and 9 sevenths, right? Those would not be like terms because they wouldn't simplify. Right? To help them see that if they're not like terms, I have to do something. If I can make them like terms, I could, but a lot of the times we're going to see that we're not going to end up with like terms. And so that's where the distributive property is so powerful in this. You might want to remind them that we also went back in lesson 5, that we're seeing that the distributive property is how we multiply really any two numbers that are bigger than 9 times 9. Right? As soon as I have 10 or 11 or 12 times something, I'm actually going to be using the distributive property, even though it's hidden. So for your students who are maybe a little bit more advanced or looking for that depth, there's something you can go back and look at the charts in lesson 5 to explore the distributive property a little bit more deeply. Anybody have anything they'd like to share about quick flip arithmetic or the distributive property? In coming weeks, I won't talk through it. I'll encourage you guys to participate a little bit more, but I just wanted to give you some ideas and background for using this in community.
I love this because it's a great transition for that Challenge A student from their memory work and working with those things and foundations and a little bit of an essentials. And then it's a wonderful, beautiful transition to actually think about it and put it in application in quick flip arithmetic. I love it.
Yeah, this book is a great resource, and we've talked about it before, especially for those families who are looking to add in a little bit more computation practice at home. You don't have to wait until lesson 21 to use quick flip arithmetic. Um, but if you haven't explored that before, I really encourage you to do so. You can buy a hard copy of that, but it's also available on CC Connected. And Babs or Shauna can probably put a link to that in the chat.
Quick clarification. So for each of those categories, the write, read, and calculate, they can write whatever equation they want. Like I'm thinking in our Challenge A class, tutor to class, or are we all writing the same thing together? Or
Well,
any of the above?
I would say whatever cards I've flipped over, I would
Oh, I
encourage them
see.
to write, right? So here's my card. So how am
Mhm.
I taking that and translating that into
The
my
distributive property.
distributive property? That's what
Got
I
it.
would do.
Got
So you
it.
could, right? And if you were doing this fairly quickly, you could flip several times, or you could flip different cards for different students, depending on your timing and your students um, in your class.
Okay. Thank you.
Oh, you're welcome. All right, so let's go ahead and
I
move
have
to
one more. Oh, sorry.
oh, go ahead, Nicole.
I noticed that in the playing cards where you have to assign like Jack is 11 and Queen is 12 and all those things, that was getting clunky. And then we didn't really get to practice the 14s and 15s very much. So I just wanted to encourage people. You can kind of use these games with your own cards. I made my own that go up to 15 with 4 books, and it really helps them to use these cards. And you can use them even if you just did index cards or whatever, so that you could also have the practice with the 14s and 15s. So that's all I want to say.
That's a great point, Nicole. And we'll talk as we go on, right? I could even turn over 2 cards per number, so I could end up with double digit numbers that way. So there's a lot of ways, yeah, make your own cards or turning over multiple cards. There's a lot of ways that you can adapt these games to practice with different kinds of numbers. So feel free each week to, if there's something that you've done, please share those tips because I think that will be helpful. All right, so taking a look at our cover, what do you think about this piece of art? Why might we have chosen this piece of art? Or does it remind you of anything from Foundations or Art Time and Foundations?
It looks like it's from a culture different than mine, which would then point to geography, which would, and also a place in time is kind of a location.
But Jill, would you say this is a modern piece of art?
It doesn't look modern to me. And it looks like if I went to see it in person, I would expect it to maybe even be cracked or, to have been around a very long time.
What are some of the things that might make us think that this is an older piece of art?
I think the coloring, it doesn't look like, I don't know. It seems old because of the colors. That's what my group next said.
Well, it's also the um baby Jesus. I'm assuming that's baby Jesus, like the Madonna and the child. Baby Jesus is depicted as a small man versus a baby, and so that was very common I think in the Byzantine area, and even Mary's face is not lifelike. It's very, yeah.
Yeah, I was gonna say it reminds me of the Madonna and Child from Challenge 2 that we've studied, and Byzantine with the gold halos. That's a Byzantine item.
And yet it looks a little muted. I don't know what the word, like in that era, it looks like somebody was copying that period of time. So while it's old and indicative of things that we looked at in challenge 2, it looks like maybe it's a newer version somebody was imitating, and there's a little bit of modern to it because the halos kind of blend together versus the gold or foil that was used in that time period.
Yeah, the gold halos were what I noticed first when I was looking at this, because I remember in our foundations community, right, that was one of the artists that we sort of copied, was an artist who used those gold halos a lot.
This looks very geometric to me. I'm sure it has to do with the fabric and the halos, but it feels like there's a lot of geometry.
So what geometric shapes do you see, or geometric relationships do you see?
Well, it almost looks like those translations and transformations we talked about, because on the fabric, the image is the same, but it's oriented in different directions, is one thing.
Anything else? Does anybody see a dilation?
Yeah, I was thinking of dilation with the child's and with Jesus and Mary's halos.
That's what I was thinking. But then when you said that about the dilation, going back to somebody earlier said that style of art where instead of having Jesus being a baby, right, that we see Jesus as a little man. So which is a better illustration of mathematical dilation? Jesus is a little man or Jesus is a baby?
A little man.
It's an interesting thought, isn't it, that when we have our babies, we recognize them as being people, right? They're really clearly people, but we don't grow, right? If you think about our scale factors, and we talked about, there's a horizontal and a vertical scale factor in the 2D plane. But when we grow, we're we're not growing sort of all of our scale factors aren't the same, are they? Our proportions actually change as we grow. I'm not sure what that means, but it feels, I don't know, it just feels kind of like an interesting thing to think about, that God knew, right? Like if I was, if it was me, right? If I was God, I would go the easy way is you get a small copy and over time, right? You just grow. This would be the mathematical way to do this, that, you know, after 2 years, you've grown by 1.8 and so forth, right? That there would be this growth factor that would be steady and all of your parts would just grow. That's not how we work, right? It's a way more complex um, process than that. And it makes me think back when we read It Couldn't Just Happen, right? It's one of those things like that can't just happen. So seeing that and going, okay, that might be how man pictures, right, us growing, but God does something different and more beautiful, because we get those sweet, soft babies that we can hold, and somehow holding and snuggling a little like scaled down version of a man just doesn't feel as cuddly, does it?
Yeah, in the same way I was thinking about the comparing, her face looks so elongated, and then, his face looks rounded. So it's kind of the visual of what you were just saying, that you grow over time and there's that change.
Does she look happy?
No.
So here's a question, right? I have no idea what the answer is, but do you think that Mary was a sad person for most of her life, or do you think she was a joyful person most of her life? Or at least when she was being mom to Jesus? Like, is this an accurate depiction, do you think?
I like to think that she was joyful, but that's just maybe what's been portrayed to us, in whatever pictures or movies or things we might see. But I like to think she would be joyful, but also I would imagine just having this, Lord, you've put me in this place as the mother of your son. How do I mother this? I don't know, almost so perplexing. But I think there could be sadness later in knowing he was leaving. Um, but hopefully joy in that too, and if she had understanding of the purpose of that. I don't know.
I guess like any motherhood, it was probably lots of joys with lots of struggles. Although I did read one of those sort of fictionalized accounts of Mary, and it made me think. I was expecting, I think, my second at the time that I read it, so it felt more meaningful. But it talked about how, she has this baby who is God and perfect and sinless. And so she is a great mom because she's got this great kid. And then the next one comes along who is not sinful, right? I mean, who is not sinless and who is not God. And so, um, not, I'm sure, I don't know. I mean, I just know me personally, it would have been really kind of easy to forget. Like, you just get caught up in the everyday life, right? And so I'm just a good mom and I have a good baby. And then the next one comes along and you go, oh, that's right. That one is God. I'm going to read our quote just because I think it's a quote that we've had sort of floating around since we began. Um, and it says, "Man's mind, once stretched by a new idea, never regains its original dimensions." And that's Oliver Wendell Holmes, right? And I think that kind of goes along with our idea of seeing the unseen, right? That when we're looking to see the unseen and we see new things, it's really hard to go back and be ignorant, right? Or go back and not be aware of that wonder. And now that Lee's on the call, I will just say, happy anniversary to us, because Sunday will be 8 years since Lee and I first sat down to talk about the math map. So Lee had been working for a long time before that and praying for a long time before that, but that's the first time we sat down and things started to take the form that you see today.
Praise God for that.
All right, so let's go ahead and we're going to take a look at our I squared and I cubed pages. And so as we look at this I squared page for invention here, let's go back to our basics and just what do we mean when we say, right, let's define dimension.
Maybe space to work in?
Okay.
Well, I think back to that first week when we had the chart of the characteristics of each of those. And so I just think of like there's like length and width. And so like all the characteristics. So maybe just kind of, could the definition be like some of those characteristics, or the headings of the characteristics maybe?
Okay, that's a good resource.
Do the limitations of each dimension help define dimension?
They may do. If we were explaining this to our children, right, so you're all pulling in lots of great knowledge, which is fantastic. But if we were to try to simplify this, and let's say our kid said, well, Mom, just what do you mean by dimension? If I was going to say, I'm sending you a box and the dimensions of the box are 4 by 6 by 8, what would that mean to you?
That you can measure it 3 different ways, or 3 different measurements are needed to get the idea of the whole thing.
Okay, so you just said there's 3 measurements, and how many dimensions are there? 3 dimensions in that case, right? If we were talking about a piece of paper and I said my paper is 8.5 by 11, right? How many measurements do I have? And how many dimensions do I have? So we get the sense that when we're talking about dimensions, we're talking about almost a direction, right? In which we can measure something. And what has to be true as we add dimensions, what is true about how those sort of directions line up to one another?
90 degrees apart?
Excellent. Yeah, they're all 90 degrees apart, right? So if we, and I say direction a little bit lightly because each dimension has 2 directions, right? If we have an origin, I can go left or right, up or down, but we're still sort of talking about, I'm going to use that term direction. So we're talking about a direction that I can measure something in that's at 90 degrees to any other direction, right? So it's important sometimes, right, to go back and say, okay, what do we mean when we say dimension? And then we can start adding all of those other things that we know to help us to expand on that, right, and see some of the patterns. So let's zoom out now and talk about, again, our invention page. And this is where we're encouraging our students to invent and to think so we can use our common topics, but we can also use our tell me everything you know question. So our title is location. So what are some things that you know about location?
Well, it is definable.
Good.
It's a point.
Okay, it might be a point.
It
You
can
can
have,
find it in different directions, like north, south, east, west, or up, down, left, right.
Good.
it can have coordinates.
If I want to talk about location, does it have to have some way of applying coordinates, even if they're not mathematical coordinates?
Well, you
Do you
could
mean-
use landmarks, but you also kind of need an origin, a place where people would be coming from.
Good. If I was kidnapped and put in an all white or all black room, so I have, let's say all black, right? Like a sensory deprivation room, right? So I have absolutely no idea where I am, how I'm oriented, anything. Do I still have a location? Yes.
Yes, it's just unknown.
It's just unknown. But in order to communicate that location to somebody else, I need to have the origin. I need to have, and then I need to have my system of addressing from there, right? So what are some of the ways that we in our world, right? So thinking just in our human space, what are some of the ways that we might know our location?
GPS coordinates.
That's a nice specific way. Yep.
What's around us?
Okay, good. So somebody said landmarks. So landmarks can help us. How do we get mail?
Our physical address.
Our physical address, right? Or a mailing address, right? So you have your address that might be your road, right? If you're just talking to your mom in your house, right? You necessarily use your GPS coordinates.
No, you use lots of prepositions though. I'm in the kitchen, by the window, you know.
So those are more like landmarks, right? So depends on what kind of communication, what location we're trying to communicate. Right? I might say, hey, I'm in the screen room, and everybody that's at my house knows where I'm at, right? But if I said that to everybody there, you might know a little bit about my surroundings, but you might not know specifically where I am, right? So I think it's a fun thing to talk through with our students to help them start building that sense of location and how do we communicate that to one another? Because let's face it, a lot of them are used to looking on their phones, right? And you look at your Life 360 or your Google Maps or your Snap map or whatever, right, thing you're on, and you can see where everybody is. And so you see it on a map. But being able to communicate that, there's a lot of different ways that we can do that. One of the things that I think is fun, but have not found any way to incorporate it into my my life is the I think it's like what 3 words or what 4 words, but a group mapped the entire world into like meter chunks, and so you get like 4 words to describe where you are, um, which is really kind of fun, but it has no practical purpose, and I haven't figured out how to like advertise that to anybody. Like, hey, this is exactly where I am right now. So, but something fun, if you're having a conversation with your students and they enjoy this, that may be something that they might like to explore. Now, here's a quick question for you before we move on, because we're talking about 3 dimensions, but we're also talking about human space. What would be the difference between how we communicate our location in human space, right, on Earth, to how we might communicate location if we were looking at Earth as a sphere?
That's when we would get into angles, talking about changing our degrees.
Okay, so we might use some angles. Good. So when we use those angles, somebody said GPS coordinates. What do your GPS coordinates usually come in? How many coordinates do you usually get?
Latitude, longitude.
Latitude and longitude. So 2 coordinates, but yet how many dimensions are we in?
3.
3 coordinates, right? So there's something to talk about with our students. Why do I only need 2 coordinates? What is that 3rd coordinate?
Well, we're stuck on the surface of the earth, right?
Exactly, right? So we just sort of negate the radius, right? We don't worry about that. When we talk about latitude and longitude, we're talking about 2 different angles, but we just kind of pretend that the radius is constant, even though it isn't. And then when we want to climb a mountain or fly an airplane, all of a sudden that 3rd coordinate really matters, right? Or if we're going to go deep sea diving, that 3rd coordinate then really matters. But a lot of the times we're just assuming that we're all about the same distance from the center of the earth. All right. This page looks a little bit different. Notice it says it's conic sections. So what are some things that you could name on this page?
Ellipse.
Good.
Well, from previous weeks, I would know the parts of the circle like the radius and the center. So that would
Good.
be familiar.
Axis.
Good.
I see that parabola and that just blew my mind because I was like, oh, that's why we graph those in cones.
So remember, you don't necessarily have to know these things in order to be able to name them, right? So we could just let our students read in order to name, right? So we could say we're going to name a circle, name, right? We're going to read those names of all of these labeled diagrams. And that can be really accessible to all of our students because they don't have to memorize it yet, but this is a part of our memoria, right? The core habits are part of our memoria. And so helping our students to practice those by naming, right? And in this case, that could be reading the conic sections or reading the parts of the conic sections. What about expressing? I have an idea for how you could express the idea of a cross section. Does anybody else have any ideas for how could you help your students to understand what a cross section is?
Well, we could certainly find something manipulative to do, but like my kids used to read some of those Stephen whoever books that did cross sections of a castle, cross sections of a cell. So like lots of, so they might have, if they'd seen those things, be a little familiar with that idea, or a dollhouse that they played with, or something like that.
Good resource.
Could I just cut an apple or a banana and look at that piece?
Yeah. So I was thinking of a potato because, right, those sort of potato stamps that you can make, but right, so you could practice taking a potato, even though it's not cone shaped, but we could still see how, depending on where I cut it and the angle I cut it at, I could get some really different shapes. So there's something just to help, again, just to help our students to get the idea, right? Not necessarily with a cone. That would be great if we had, right, cone shaped potatoes we could use. But, right, just to get that idea of, oh, that's what I'm doing. When we talk about slicing this cone to get these sections, that's what I'm talking about, is if I sliced it off, what would that slice look like? And depending on how I slice it, these are the only shapes I could possibly get, which I think is kind of cool, right? I always think it's really kind of neat when you think there's an infinite number of ways that I could slice this cone, but there's a finite number of shapes that I could get from that.
That made me think of antithesis, what you just said from Lost Duels. It's like, yes, contrasting ideas in parallel form, but
Yes,
it
that's
blows your
great.
mind.
Does anybody remember seeing these conic sections in another lesson?
It's the
There's a
parent graph.
hint. Sorry?
Is it a parent on the parent graph, the parabolas?
Good. So we saw parabolas. We've seen those on the parent graph. So that would have been back in lesson 11. And anybody remember what lesson had circles in it?
16? Well, that was triangles and circles.
I think 13 was circles and ellipses, but solid shapes would have shown some of those bases. So it's not a cross section, but it does carry the shape.
Good. So we could go back and look at 11 to see some details about the parabola, especially the vertical parabola. We can look at 13, and 13 actually had all of these 2D images. So let's attend for a moment. How many variables are in each of these equations? And the variables are the letters that are italicized. So not the A, not the B, not the H, not the K, not the C.
So the two, the X and Y.
Just two, right? So if there's two variables, how many dimensions are we looking at those in?
Two.
Two.
Two. So that's what we were doing in 13, is we were taking a two-dimensional look at these conic sections, which we can do, right? We can look at these and understand these shapes because they are two-dimensional. Here in this lesson, we're saying, well, wait a minute, there's this really cool thing that these shapes actually came from an intersection of a 2D plane with a 3D object, right? And so we're building on that knowledge now. So we're still talking about 2D figures, but they come from this idea of this 3D-ness. And if you've heard us talk before, right, when we think about these patterns of dimensions and these ideas of shadows, right, that here we go, we've got this cone, this double-ended cone is the whole thing, right? Depending on how we slice it, we only see this one little piece of it, right? And we might look at each of these different shapes and they don't make us think of a cone all. Some of them might think more of a cone than others, right? But they're all give us this idea of kind of what a shadow of a cone might look like, right? And so I always love to see that progression of like, okay, this 2D thing goes to this 3D thing. And then it makes you go, okay, well, how might this 3D thing, right, reflect some 4D thing? And this idea just now, right? Like, so I don't even know like that if I should say this, because this may be way too far that I'm taking this analogy, right? But if you think about the body of Christ, right? If the body of Christ was, right, is this multi-dimensional thing, right, that we're all a part of, but the parts of it that intersect with 3D, right, depending on how we're sliced, right, you get us. All right. So is that somehow like, is the interconnectedness of the body something that's happening in those other dimensions? I have no idea. Probably not. But it's just fun to think sometimes, right? How do this thought of things being in other dimensions, of these extensions being in other dimensions, how can that maybe just help us to think about things that are happening in the heavenlies that we can't see here?
Well, our faith tells us that there is the other dimensions, the unseen that we can't see. And one of my connects was back to the I numbers are like that whole realm of the spirit that we don't know. Some things work well with, but it's like, that's them.
All right, so let's take a look at our charts for this week. And we've been having some good conversations, so we are getting a little bit close on time. So let's go ahead and take a look. And what I'd like you to look at here are what is familiar, because we've seen it in 2D, and what is unfamiliar, and how are we connecting the two things together in this lesson?
Well, the pictures are familiar because we've seen them in other lessons. The pictures at the top, like of 0D, 1D, like we've seen those in other lessons. We just looked at the 3D picture because we were on week 20, no, week 19, where the 3D box of the octants where you could see them. So that's familiar.
Good.
I like how at the bottom it has the 2 to 3D correspondence, because it says like in 2D it's a polygon, but in 3D it's a polyhedra, right? And so it has those connections there. And then of course has the pictures, which makes it all better because then you can see what they're actually talking about.
How do you say that word after prism? The how do you say that?
I say it parallelepiped. That doesn't necessarily mean it's correct, but that's how I would say it.
I think something piggybacking off what Bab said is you look at that bottom section, the 2D and the 3D, and I think this section lends for a great comparison conversation with the class.
Great. Because that's what we're trying to do, right? Is we're trying to build new knowledge on the knowledge that we already have. So let's compare what we know from 2D to this idea from 3D, and how does that help us to build those pegs? Do we see that same progression on chart 2?
Yes, but I think this one's more fun because it has more pictures. And they're colorful pictures and they're small and don't have a lot on them that you have to memorize.
I'd say the colors, the math map's done a really great job of representing different things with colors. And as someone who appreciates visual images, these colors really help and add to the depth of the lesson.
Well, it's great to hear. I will say Lee is an incredibly detailed person, and so she has really worked hard to make us be consistent, to make us choose our words and our images and our colors wisely, and to be consistent throughout the lessons. It's not always perfect, but she's continually going back and looking to make it better. So I'm glad that that's been helpful. So before we move on from our charts, I just want to address the word locations, and I want to invite you to look at the almost at the top here. Let me my pointer turned off. There we go, and it's still off. I don't know why you can't see my pointer anymore. I'm sorry about that. But look here and here, and does anybody see that word and know what that word means?
Loki.
Loki, yep. What language are we talking about?
Latin.
Latin. And so what would be the singular of this, do you think?
Us.
Locus.
Locus.
And what does locus mean in Latin?
Location.
Location, yep. So we could have called this lesson, all right, Loki, but we called it locations to be a little bit more friendly and also to draw a bigger picture of what we're talking about. I do want to stress that when we're talking about a mathematical locus, we're always talking about the sets of points that satisfy some given condition, right? So if I said, here's a center and you want the set of points that are equally distant, right? Well, all of the points that satisfy that condition, my circle, right? And so the circle is the locus. And so while we're talking about this broad idea of locations, especially in human space, right? we're still talking about satisfying given conditions, right? So what condition does my house satisfy? Well, it satisfies that it's in the United States, that it's in North Carolina, that it's in Moore County, that it's in Seven Lakes, that it's on Longleaf Drive, and that it's number 216, right? And so those are all the conditions that my house has to satisfy, right, in order to be where it is. Right. And so when we talk about a locus, we're saying here are the conditions. Now, if I had not told you the number, right? And hopefully people like me. And now that I've just like revealed my location, people aren't going to be like, track her down and like get her. But right, if I hadn't given you that, well, you wouldn't know exactly, right? But you would say, well, anywhere on this road, right, satisfies that locus. Or if I hadn't told you the road, you'd say, well, everywhere in Seven Lakes is the locus, right? So we can still talk about a locus in terms of our human space. But when we talk about it mathematically, we're really going to be more specifically looking at um, geographic or algebraic, right, descriptions of points. All right. So I have lost my, there we go. I had everybody in front of my advance at the slide. So does anybody have any questions or testimonies that they would like to share from last week?
One thing that we had our science fair yesterday, and one of our students in his research paper talked about how his project was a part of seeing the unseen. And so he was like, do I get extra credit because I put math in there? I was like, well, I'll tell the judges and see what they say.
I love that.
Okay. I don't know if it's specifically from last week, but it has impacted me. So I wouldn't mind sharing. I'm reading through the core, and I came across a sentence or a scenario or picture about the grocery store. If you've read the book, you probably know about the grocery store. But it has impacted me in a way that I did not expect, because I don't know why. It's like the simple question was something like, can you, in the midst of potentially tens of thousands of products, tell someone where to find the egg, or tell someone where to find the bread? And the answer is yes. And that's because your brain has the ability to categorize and hold way more information than you think you can. And I put the book down and suddenly was like, that's why the math map is working for me. And I really thought I would hate the math map. I really did. And stop. I don't mean it in a mean way. I seem like I'm struck by how I'm able. I think earlier this year I asked, why is this still so hard? And I'm struck by it now. I feel like it's actually easier. I'm almost scared to say it, and because I know there's still quite a few weeks left, but I think that just struck me was this understanding that I don't even know what I can do. Much of what our kids and ourselves can do is subconscious, but if we pursue it, we probably can do it. And I don't know if my words are actually expressing the profundity of how that hit me, but that has really been powerful for me in the last few days.
Well, Nicole, I love the way that ties into this whole idea of location, right? Right? How can I know where the eggs are? But now the math map is giving you, right, a way to locate your knowledge and connect it in ways that haven't before. That's beautiful. Thank you. So again, looking at our page tops, and I heard somebody earlier say, well, Lee says these are the most important things. And I think one of the things we really want to emphasize is that, again, coming back to this idea of a map and that graphical memory and seeing sort of the picture of things that Lee has tried to put the graphs and the images that are going to be most helpful in those page tops. So it's not necessarily like, here's all of your grammar, but that these are some really solid pegs that are going to give you a picture to hang other grammar off of. And so that's why we really emphasize starting with these. So this first page here, notice it says 2D to 3D correspondence. On the left-hand side, we have a 2D image. On the right-hand side, we have a 3D image. And these are all going to correspond to those correspondences, using this word a lot, on chart 1. So on the left-hand side, it says every point on a circle is a distance of 1 radius from its center. And then it says, given the radius, sketch the locus called a circle. Right? So our students are going to sketch. And this is a good opportunity to review our word sketch, that sketch is not drawn using a tool. It's not constructed to be perfect, right? We're just drawing it freehand. And where necessary, we can put in markers, right, to show things that are true. In 3D, right, notice the parallels between our two loci here, that every point on a sphere is at a distance of 1 radius from its center. So in 3D, that same locus description, right, we're going to get a sphere. And so here, our dashed line means at the back and at the front. And notice, because of our perspective, our radii are all congruent, but they're drawn to be a little bit different to give us that idea of its perspective. And so that's our locus, that's a sphere in 3D. On page 2, we're going to continue, right? We're looking at 2D versus 3D. And so on the left-hand side in 2D, we sketch a circle with the origin as the center and the radius. So encourage your students, if they're not Giotto, it's okay for it to not look like a perfect circle. And then we're asked to copy the circle equation. And so this is a great opportunity to ask your students, how many variables are there that you're copying, right? And I have 1, 2. On the right-hand side, we're asked to sketch the sphere with the origin as the center and radius r. And so here we don't have it to trace. And so we might have to help our students to remember what that's going to look like. And then here you might notice we're in 3 dimensions. So how many variables do I have? I have 1, 2, 3. And so 3D, 3 variables. Any questions on either of those page tops? I think for the most part, you're going to find those to be fairly straightforward in this lesson, and helping to build that familiarity over time with what those loci are. Don't forget, we still encourage every week for our tutors to still be working through the logic catechism, reminding our students that they have the solutions and that they can work backwards, that they have more conversation starters on the inside back cover, that they can play games using the game on the back cover, that the careful calculations is a way to review or test calculations that are related to the concepts. The flashcards are there, and we should still be using those to help our students really build up their fluency in the language of math. I'm just going to give a shout out to Babs, because I know that Babs has been diligently working on memorizing all of the notations flashcards. And she is actually in the master's, one of the master's classes for math. And so I get an update, like how many flashcards she's got left to the master. So I just wanted to give her a shout out there because she's got a testimony that this really works. The companion is there for the parents so that to help you answer your students' questions or to answer your own questions. And then obviously the lesson pages are there to help practice those concepts. And we are here for the families as well. We are excited now that we've launched the Challenge B parents forums, as well as having them there for Challenge A foundations and essentials. We've got the companion is getting close to having all 30 weeks loaded. So that is there for you. Next week, you will be working on populations. I will not be here next week. So Jill Philbrick is going to bless you all by leading next week with Lee. And then after that, we'll be jumping into the fourth dimension and talking about matrices and rates. So those are our upcoming lessons. And so that takes us to our time for questions. If anybody has questions that they'd like to go over before we jump off.
I have one quick question. Last week you introduced the term torus to us
Yes.
in the homework, and I couldn't find where it was introduced outside of the answer key. Is that can you help me with that?
Sure. The torus, a torus is on chart 20. Page 2, chart 2 of lesson 20, down at the bottom hand side, where we talk about a torus. The torus comes from the study of topology, which is a study of surfaces. The interesting thing about, so here's a washi tape, right? And if you think about this as though it was a solid, it really just has one surface. Right? Because I could trace everywhere with my finger. I don't have to change to something else, right? Because if I think of it as a surface, there's not an inside and an outside. It's just one surface, even though it has a hole in the middle of it. And so when we think about a torus, we usually think about it as being a donut, is a good example of a torus. But in the study of topology, I think it's really interesting because you think about, they sometimes call it rubber sheet geometry, because it's the idea that you have a surface that is infinitely stretchable and malleable. So I could look at, for example, a bowl, right? And topologically, this would be the same, right, as a piece of paper, because I could stretch my piece of paper to make a bowl. But it would be different to my washi tape because my washi tape has a hole. But my washi tape would be topologically the same as my mug because my mug also has one hole. But these would be different, right, to my glasses if I took my lenses out, because my glasses would have two holes, right? And so when we think about it, the study of topology and surfaces and the torus, we're usually interested in how many holes there are in the surface, because no matter how you stretch something, right, I can't make more holes or fewer holes, but I can make all these different shapes. And so that's a fun way to sort of stretch your brain. And that's a very simplistic view of topology. And my understanding of topology is not that much deeper than that, but it is a lot of fun to think about. And so a torus is just a little bit of an introduction to that idea of topology, helping students to see that when we think about this solid geometry, it's not just our polyhedra or our spheres, that there's all these other shapes that we can explore and discuss and study. Does that help?
Yeah, I think more specifically, I was trying to figure out how we would have known that answer without looking at the answer key. And you're saying it's on chart 2. So I can go back and explore that. I appreciate it.
Sure.
I have a question from Transformations, which is booklet 18. It's hopefully quick. I just wanted to make sure, or just clarification, I guess. So the capital P, and I got my flashcards out. I'm like, did I miss this one or did I not remember it correctly? Is that our, oh, what is the word I want to use? Expression, notation for transformation is that uppercase P. So like I'm on page 1 on the top.
So what you're talking about, right, is where you see this.
Yes. Yes.
So that just means my point. That is Lee just saying point P, which is at location X, is
Okay.
being transformed to point P prime. That's like, let's say location X plus 3.
Okay.
And so that's all that means, is that this is some generic point P and its image P prime.
Okay.
And then whatever I'm doing to X is kind of the rule for the translation, or in this case, translation or transformation.
Okay. So it just happened to be given the letter P. There was no particular symbolism. And then
No.
my other question is, so on that equation that you wrote there with the arrow in the middle, the way that the arrow is drawn in the book, it has like a
that?
yes. What do you say when you see that symbol? The transformation?
Yeah,
Or
so note, so this is a great example where Lee has been very specific about being careful to use as much as possible notation that is specific to different ideas. So, right, when we talked about limits, we would read this as X approaches infinity. And so she chose to use this arrow that has this little bar here, just to differentiate between the
okay.
two.
Okay,
Right.
that makes
And
sense.
so I would, if I was reading this, I would either say the transformation from
Okay.
P of X, or from point P to point P prime, moves from X to X plus 3. Or recognizing this was a translation, I might say the translation from P to P prime is from X to X plus 3.
Perfect. That makes sense. Thank you for
You're
clarifying.
welcome. Any other questions or things anybody would like to share before we wrap up for today? Well, as ever, thank you so much for joining us today. It's been fun talking with you, and I will miss seeing you all next week. But I know that you're going to be blessed to hear from Jill, and hopefully you'll still want me to come back the following week. And I will be praying for you all. So have a great week.
Thank you. God bless. Bye.
Thank you.